Assalamualaikum warahmatullahi wabarakatuh and hello everyone. My panel for this project presentation is TS Dr. Aliza binti Cik Amran and TS Muhammad Razali bin Muhammad Syafi'i. Before I start my presentation, let me introduce myself. My name is Muhammad Syukri bin Abdul Halim. I am currently 4th year student in Bachelor Electrical Engineering, Technology, Automation, Industrial and Robotics at UTM. I would like to present my bachelor degree project with my title IoT based smart home automation using solar system. This is my full overview of my poster bachelor degree project. So for the introduction, the project is implemented to run the smart home automation system using a solar system. This is project allow the automation system to be run for 1 day by using a solar system that will generate energy to the home automation system. The project can also control electrical appliances at home and can also monitor the voltage on solar battery to ensure the system does not shut down when there is not solar source. And next, for the objective, want to design power supply based on solar system for smart home automation control. 2. To integrate smart home automation with home electrical appliance. And 3. To develop mobile application for control and monitor home electrical appliance. For the problem statement, people always forget to turn off the light switch and fan at home. Some people also forget to turn off electrical appliances in the house such as rice cooker and television. This will cause the cost of living to increase to pay electricity bill and people do not want to happen always. And for the scope of projects, create a smart home automation controller system powered by a solar system where the ESP32 will be controlling several of electronic components such as relay. And 2. User can control the electrical appliance at home and can still have to access the internet because the power supply for the Wi-Fi router is from the solar system. That the solar system cannot be run if the weather is cloudy throughout the week. So next, the methodology. My project has 3 parts. First, supply from solar system. Second, controller system. And third, output loads. So the solar system is a main supply for my projects. Solar panel that use is 100 watt 12 volt battery cell lead acid 12 volt 7 amp hour and solar chargers that keep batteries overcharging. So next is controller system that is consists of ESP32 relay, LCD and LED indicator. And then ESP32 is a microcontroller that give signal to trigger the relay to on off the electrical appliance and send signal to display the LCD and LED indicator. So next, so for my prototype this project, this is my prototype for this project. So this is a dB supply from the grid, and this is a 2 load. This is my system control system that have a LCD, LED indicator, ESP32, relay and voltage sensor inside this box. So this is my battery solar, battery cell lead acid 12 volt, and this solar charger. This is a inverter and this is a router for internet. So this is a switch for on off the appliance electrical. This is my IoT interface. So we can see this in offline mode. So when we turn on the system, it will display welcome to IoT based smart home automation using solar system. So when a Wi-Fi not connected, the LED red indicator will light up, and when Wi-Fi connected, LED indicator green will light up. So we wait for the second to Wi-Fi connected. So when Wi-Fi connected, so the application for smartphone can use, and we test to turn off the light. So when we turn off the light, the indicator at the smart home at the smartphone will turn off, and at LCD can also show the turn off for appliance ones. So when we turn off another appliance electrical, also the interface at blink will turn off, and at a LCD will off for appliance too, and for appliance electrical also off. So we switch on from the blink application. So as we can see, when we turn off from the blink application, so the LCD also display appliance once on. So the so when we turn on for when we turn off the appliance one from the blink application, so we can see the LCD all will display off, appliance once off. So for test the Wi-Fi connected, so I'm use the my my Wi-Fi to turn off the Wi-Fi. So we can see the Wi-Fi not connected in this situation. For so when Wi-Fi not connected, the LCD will display Wi-Fi not connected, and LED red will light up. So when Wi-Fi not connected, so we can use a manual method to turn on the appliance electrical. So when we turn on, use a manual method, manual switch button. So we can see appliance 1 and 2 is function. So we turn off again. So we turn off the appliance electrical. So as we can see, the manual method for this system is function as well. So when Wi-Fi not connected, it will function, and Wi-Fi connected will function with the blink application. Next, for the result, this graph shows the full system output voltage for solar batteries and solar charge controller with two different loads from solar charge. As we can see from the graph that with load ES USB 5 volt, that this system can operate 24 hours, while with load 12 volt the system can operate 2 hours only because of the load. For the runs, for For run the control system in 24 hours with bigger load must have the bigger battery capacity and bigger power watt for solar panel that can charge the battery faster. So for the conclusion, all the objective we achieve since the overall system development and evaluation process was success. This smart home automation system using solar panel success in controlling electrical appliance and power up system using solar system. So that's all.